Descriptive statistics. All right, so that's the word we give this. By the way, as we work through these statistics and some of this probability over the next couple units, all right, this might be something that you may want to take next year as a course. You got AP statistics that many people will want to go take. So you'll get a sampling here of if you like it or if you don't like it, and whether or not you might want to take it or not. Okay, so we're going to look at some vocabulary here early on. And so the first thing that we have is univariate analysis. Okay? Univariate analysis. All right. So univariate analysis involves a single variable like, say, like the height of everybody in class. Or maybe the test grade from yesterday in class, or your shoe size, or whatever. I'm picking one thing and I'm looking at that for each person. All right, univariate analysis. All right, that's actually what this unit's going to be about. We're going to look at one variable. We're going to handle that. The other one that we'll discuss is bivariate analysis. Okay. You have done bivariate analysis before, all right? We're just going to call it bivariate analysis, all right? So if I'm comparing my shoe size versus my height, if I'm comparing my studying versus my grade, or if I'm comparing two variables, what do? I know, sorry, that was kind of touchy, huh? All right? That is regression is what we do a lot. So we can do linear regression, we can do quadratic, we can do exponential. So if I'm comparing two things, all right, that is regression. So we've talked about that before in the past, and we'll come back to that in a week or two, okay? So that's kind of two different things. We're going to talk about univariate in this unit, okay? All right, so let's go next. So we can classify them again. When we collect data, by the way, I like to use these, I do these statistics earlier on because many of us might write a statistical paper that you'll want to have some of this in. So one of the things that you could write with your IA is you could do some type of analysis and you can go collect data, all right? So when we collect data, there's two different types of data we can collect. We can collect qualitative data or quantitative data, all right? Now, if you don't want to rewrite these words, because I can't spell them most of the time anyways, all right, you just draw an arrow, that's fine. Qualitative data, all right? Qualitative data goes in that first blank, all right? So qualitative data is seen in a lot of surveys. It's what is your favorite food? What is your favorite TV show? What's your favorite subject? What color eyes do you have? All right? Those are qualitative data, all right? Can you measure eye color? Not really easy, right? You can maybe assign values to them and stuff, but it's hard to measure eye color. It's hard to measure what your favorite food is, all right? Those don't make any sense. Now, quantitative data is probably what we want more, and so quantitative data is data that can be measured, all right? What is your height? What is your age, all right? What did you score on the SAT? What did you do this? You can measure all those things, okay? You can put values to that. And so when you build a survey, if you're wanting to do a survey for your IA, we want to build a quantitative survey. We want to be able to collect the data that way, all right? Everybody good there? Okay. Now, you see kind of why I gave you the notes this time around. There's a lot of words and a lot of writing in here. I'm trying to save you a little bit there where you're not having to do all that, okay? All right, now, we could take this data and we can categorize it another way as well. We can categorize it into discrete versus continuous. Now, a lot of times they like to ask this question real quickly. It may be worth 1 point on the test, all right? What is this table? Is it discrete data or is it continuous data, all right? Discrete data. Discrete has exact numerical values. So the discrete is this first one. Again, if you want to draw arrows, you can draw arrows. I don't care. Okay? Discrete data there, and it's exact numerical values. Anybody think of an idea that would have discrete values in it? Height, okay? If you're gonna categorize it by a certain like inch or something like that, right? If we're gonna be round it to the nearest inch or whatever, right? We could do height, that would work. Yes, sir?
Like times you went on vacation.
Okay, the amount of times you went on vacation, you could count it, correct? What about shoe size? Is that discrete?
I mean, there's halves.
There's halves, but there's like not everything, right? You got 7, you got 7.5, you got 8. Like those are very distinct values. How many likes did you get on your Instagram post today? That's discrete data, all right? Make sense? All right? So I can count it. This is what I can do. Continuous data is data that has many different answers, including fractions and decimals and all kind of things. Now you made mention of the decimal and shoe size, but anybody wear a size 3.5 and a half, or excuse me, 3.75? You wear 3.75.
Yes.
That makes sense, okay? All right, but 5.15, you don't wear that shoe size, all right? And so we got to be careful with height. You gave height a while ago. Could height be one that's got a lot of different answers we have?
It'd be like 5'7" and 1/8.
And 1/8 and 1/4, 1/16. We could break it down where it gets more continuous, all right? What's another idea that's continuous? Age could be continuous, all right? A lot of time, anytime we're dealing with time, time is continuous. How long did you scroll on Instagram today? That's a continuous value, all right? How long did you play Clash today, all right? That is a continuous, that's a continuous deal, all right? So, see the difference between discrete and continuous, all right? All right, now, we want to collect data, and I'm sorry you don't have this one on your notes. We want to collect data that is reliable.
Hey, we have it.
And that is on there?
Yes, sir.
Okay, sorry, I thought I left that off. You're right, okay? All right, we want to collect data that is reliable and is sufficient. So if it is reliable, then if you repeat the collection process, then I would get a very similar result, all right? So if I went down during my lunch today and did a survey, all right, and got answers, and I'm going, those couldn't possibly be right. So I go back the next day and I do it again and I get the same exact results, then my data is reliable, all right, or very similar results. Now, yesterday was a weird day, all right. Sometimes on testing days, we don't test when we test, we like eat in different areas. Like sometimes when we do like the English 1 test, then all the freshmen eat together. So if I were to go survey the cafeteria there, all right, versus surveying it on a different day, then I'd get two different answers, correct? So my data probably wouldn't be as reliable there. Question?
I didn't get this paper. It's right there.
All right. Data needs to be sufficient to support it as well. All right. You can't go survey your best 2 friends and say, "Hey, everybody at Bryan High believes this." All right. Doesn't work. All right. You might make that statement, but my data would be biased. All right. And so I need to have enough data. So if you do a survey for your IA, these are some good reflection questions that you can include in there. My data was reliable because I did this. Or maybe I didn't have as reliable enough data because maybe I didn't survey enough people, okay? And so that's all kind of part of that as you go, okay? Everybody good? All right. When you look for data, when you build a survey, all right, you could give that survey to the population, all right? When we think of terms population, what do we think when we think of population? People a lot of times, okay? We're thinking people. Now, the population could be different depending on what are you talking about, like the population of Bryan, Texas, all right? That's one group. We could talk about the population of Bryan High School. That'd be a different group, all right? We could talk about the population of the IB program. That could be a different group. So depending on which group you're talking about, when we define our group, the population is everybody that's a part of that group, okay? Is there a survey that includes the entire population that you know of?
The world population.
The world population, okay. How about America? The census is a population idea. Who gets surveyed in the census? Everyone that's a member of the United States, all right? And so everybody gets that survey, all right? That's a pretty massive thing. How often do we do that?
10 years.
Every 10 years is when the census gets done. Can we do that every year? It would take a lot of effort to do that every year, correct? A lot of paperwork, a lot of time for people to do that. By the way, once they do the census, is that data good anymore? It's already changed probably. By the time they get all the results for the census, it's probably already changed, all right? And so, but that would be a situation of a population. So most of the times we see things more in samples, okay? And so they take a poll, all right? Sometimes around election time, they take an election poll, and they're surveying a group of people, all right, that they're trying to say that that represents the population, okay? If you take AP statistics, you'll be doing problems that you'll talk about the population, and you'll talk about samples, and you'll do two different works there. For IB, they merge these two things together. The sample is representing the population, is what they're saying here, all right? They're one and the same. That's how we talk about it in IB land, all right? Now, we don't really want to do a population. I don't want to, if you're doing a survey, you probably don't want to go survey everybody at Bryan High School. That would take you a lot of time to do that, all right? A lot of effort. But you might want to put together a survey that's going to be a sample. Well, in my sample has to include two characteristics that are very important. The two characteristics that have to be in my sample is that everybody has to have an opportunity of being selected, okay? Everybody gets a chance. You may not be selected, but everybody should have an opportunity to be selected, okay? And that the sample has essentially the same characteristics as the population. So it's going to be representative of the population, all right? If you have a lunch and you go survey a lunch, would this first one be good? Did everybody have a chance to be selected? No. So if you're going to do something at lunch, you probably would have to go a little bit in each lunch, correct? Don't take the lunches by yourself. Get permission if you're going to do that, all right? And so have that. And then essentially the same characteristics. How do we handle this? That's kind of a different thing. So there's 5 different ways that we can do sampling. So that's what we're going to look at next. There's 5 different ways that we can handle these samplings. This first one was misnamed. I think when I copied and pasted, it did something weird, all right? So this first one right here is not systematic sampling. It is called convenience sampling. All right. Convenience sampling. What would convenience sampling be?
Asking your best
Hey, you, come here. Let me ask you questions. Hey, you're right here. Let me ask you a question.
No.
All right. And so I'm here. I'm in like a proximity, and I'm just going to gather everybody that just kind of walks by me. Okay. Or I'm going to go sit at the lunch table with my friends, and hey, by the way, answer these questions real quick. All right. That would be convenience sampling. You see some people out and about at times that they're doing sampling, they're just kind of grabbing random people, right? That's convenient sampling. That's probably the easiest way to do this. Good? Would that, does everybody have a chance to be chosen?
Well, I mean, yeah.
I guess kind of if they're walking by, yeah, right. But if I'm going out of my way to get everybody, probably not, all right? And do you think that's going to be representative of my population? Probably not, all right? Simple random sampling. That's the next one. Simple random sampling. So I'm going to take everybody's name in Bryan High School and I'm going to put it into a hat, twirl it around a little bit, I'm going to pull out a name out of a hat. I'm going to go survey that person. Pull out another person, however many I want to pull out, 10, 15, 20, whatever it is, and go survey those people. Okay? That's simple random sampling. Good or bad?
Good.
Does everybody have a chance to be chosen?
Yeah. Yep.
Yeah, actually, they do that. Right? Is that representative of the population?
It's more representative depending, like if you get a larger sample size.
Okay. The larger sample size, the more it's going to be dependent, so that's good. So we see the sample size needs to be a little bit greater. All right? Anybody else have thoughts there?
If you're not trying to like look for different types of people, you
Yeah.
might look like the same type.
So there's a chance that it could be representative, but there's the same chance that it may not be representative, all right? I'll tell you an example. That just happened about a month or two ago. At the beginning of the school year, before school starts, all the teachers get together at one big convention, all right? And we have like a little deal, all right? And at this deal, they actually gave away like 10 door prizes, all right? So they drew names out of a hat, all right? Well, when they drew, and by the way, every school in the district's there. All the high schools, all the middle schools, all the elementary, everybody's there, okay? There was 10 names drawn, right? 7 of them were all from one school. It's kind of crazy, right? Would that be representative? Would that be representing the population? It was random. Anybody had a chance to be chosen, but it didn't really represent the whole population of the whole school district. Make sense? And so that's the thing that you run into maybe there. So systematic sampling is a little bit more organized now. Systematic sampling. So I'm going to take and I'm going to, on some type of fixed interval, I get a roll for the entire school. I'm going to go pick every 20th person. So I'm going to count down. I'm going to pick number 20. I'm going to go sample them. I'm going to pick number 40. Go sample them. All right, so forth. All right. Everybody get a chance to be picked? Well, everybody was on the list, right?
But only the 20th.
But only the 20, so I'm doing that. Could that help represent the whole population?
Yeah.
Maybe. Kind of depends on how those 20 people hit, right?
Yeah, fall.
We're trying to be random. We're trying to represent the whole. Sometimes it's productive, sometimes it's not. Okay? So then that leads me to the last two. By the way, as you see here, when I'm surveying this, what's my level of commitment as I'm going? I'm getting a little bit more involved, right, in my survey. All right? So the next two. I think you have to turn the page, right? I think we're on the next page. All right? Stratified sampling. All right? What is strata? Or strata? Not strata. All right? But strata. You might have talked about it when you talked about clouds and stuff in science class or whatever. It's the different layers of things, all right? And so what I can do here, the stratified sampling, or you might like look at rock and look at all the layers in the rock over the years and stuff like that. This is putting them in groups and then choosing from those groups. For instance, I can say, okay, here are my freshmen, and I'm going to pull 10 freshmen to go survey. And here are my sophomores, and I'm going to pull 10 sophomores. And here are my juniors, pull 10 juniors, all right? Is that still random? Does everybody still have a chance to get pulled? Yes, all right. Does this represent the population maybe a little bit better? A little better, right? Because now I had a chance to get like nothing but freshmen, just randomly pulling them out. But now I'm kind of making it a little bit more where I'm trying to represent the whole population.
But let's say you have like 50 freshmen total and like 200 sophomores.
But yeah, that's the deal. You might have different classes because normally which is the biggest class? The freshman is the biggest class, right? And then the smallest class is normally the seniors. And so I might want to pull out by amount there. That's where the quota comes in, all right? I'm still going to group them, but I'm not going to pull an equal amount out of each one. So if the freshmen are the bigger group, then I'm going to pull a few more freshmen out, maybe 15, all right? Then maybe sophomores, maybe a little bit less, then juniors a little bit less, seniors have the less amount there, okay? And I could group it somewhere else. I could group it guys and girls. I could group it by age. I can group it a lot of different ways, however I want to do this. Okay? Now, our government has a system kind of like this as well. Think about stratified sampling and think about quotient sampling. What in our government matches this idea?
The House.
The House and the Senate, right? Which one would be the House? The quota would be the House. Everybody gets a chance to be represented, every state, except how many representatives are there? Based on population, all right? You're thinking about the other one. We'll talk about that here in a second. So California, Texas, New York, they have a lot of representatives because they got a lot of people, all right? Somewhere like Wyoming has like one representative, I think is all they have, all right, because they just don't have a lot of population, all right. I separate them into strata, into the states, and then I pick the proportional amount out there, all right. Now, what does the stratified sample represent? The Senate, where what happens?
There's two.
There's 2 for every state. Doesn't matter the population. 2 for every state. Okay? So you see the 2 different ways that we kind of do that. All right? In our government, that's the same idea there. So we're trying to get a representation that's represented by the whole population. Going from there. Everybody good? All right? Where does this come up? They might ask a question. This is, what type of sampling is this? And it's like a 1-point question kind of deal. This is quota. This is stratified. Whatever the case may be. Okay? All right. Now, after we get our sample, then what do we do with our survey, with our results? Okay? So you might get this. So I did a survey. I went out and sat in front of my house, and I counted the cars that passed my house every minute. So the first minute, 23 cars pass. Second minute, 22 cars pass. 22 minutes there. You'd probably say I probably live on Highway 6 or something like that, probably, right? Live near a pretty big road there that got a lot of cars going past. Now, when you look at all this data, do you like just looking at the data like that? It's not very organized. It's not very effective. I don't really like the way that it looks. Okay? So we're going to probably put it in a table. That would be good. All right? And so I'm going to put this in a frequency table. All right? I'm going to put that data in a frequency table. All right? With the frequency table, we can also show our discrete data. So most of the time, a frequency table is going to have discrete data in it. We can show our discrete data in a bar graph or a bar chart. Okay? So that's the first thing that I'm going to do. I'm going to come over here and I'm going to build me a frequency table. All right? When we build a frequency table, whatever it is, the univariate, whatever variable we're picking goes here, and our frequency is going to go for our y value. All right? For our dependent variable is going to be a frequency. All right? What's the lowest number that we see in the data there? 20. Okay. What's the highest value you see? 28. Okay. I think you're on the other table. Flip the packet.
28.
Yeah. Flip the packet. All right. So 20. I'm going to fill them all in. 20, 21, 22, 23. All right. And so I'm going to go all the way to 28. Forgot my 26. All right. So at this point in time now, I would go through there and I'm going to just see how many are of each. So there's 2 20s. I can put a 2, or if you want to use your tally marks, you can use tally marks. I don't care. Okay. There's 21, 3, 4, 5. There's 5 of those. All right. So again, 5, or you could just use your tally marks. I don't care which way you write. Doesn't matter to me. Okay. And so I got 7 22s, I've got 6 23s, 1 24, 1 20, or 2 25s, 3 26s, 3 27s, and 1 28. Okay. Would this be discrete data or continuous data? Discrete. Can you count 26 and a half cars? No. Okay, you're counting cars, there's gaps in there. All right, so you can't count that. All right, now I'm going to take that information now and I'm going to go put that on a bar graph or a bar chart. All right, so again, if I'm doing that, my frequency is going to be over here. And I'm going to start here. This is going to be 21, 20, 21, 22, 23, 24, 25, 26, 28. Okay? I'm going to go draw that bar graph. So for 20, I should have a frequency of 2, so it goes up there. For 21, it goes up to 5. For 22, it goes up to 7. 26. Then 1. Then 2. 3. 4. Okay. With the table and with the bar graph, can you tell me a lot more about what the data is saying? It's a lot more organized. I can see it. I can understand it a little bit better, and I can go and do that. Now, if you notice, the bar graph has gaps in it, okay? Because it's discrete data. There's gaps in discrete data, all right? We're not including every single number, okay? Everybody okay with that? All right, let's turn the packet over. When we turn the packet over, here's some new data. Oh, yes, looks a lot more, okay? All right, but it is organized, so that's very helpful. It is in order, all right? So we'll use that here in a minute, all right? I've got 200 members of this tennis club. All right, and here are their ages. Now, you ever done a survey before and it asks you your age?
Yeah.
How does it ask a lot of times? Are you
it's either
from
like
12 to, yeah, it's a little range, 12 to 17, 18 to 25, 26 to 35, whatever. A lot of times we ask age in ranges, all right? And so that's what I'm going to do with this. I am not going to list every one of those numbers. That would be a huge frequency table. I don't want to do that, all right? But how could we group this in a way that might be effective?
20 to 30.
20s and 30s and 40s, just group them by their decade, that's fine. So let's do that. So if I were to do this, this is going to be my age, and this is going to be my frequency, all right? We are going to make what is called a grouped frequency table. We're going to group our values together, all right? So the first group that I'm going to do is I'm going to say X is going to be less than 30. So I'm going to say it on here. X is less than 30. So I'm talking about all the 20-year-olds or less. All right. Now, to help me with this, I'm going to count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16 are there. But then 17, 18, 19. So there's 19 in each row. All right. Now I'm only going to use the first 16 in this one though, all right? So there's 16 people that are less than 30. I counted the 19 just so I can help in future counting, all right? The next one, I'm going to say X is going to be less than 40, but it's going to be greater than or equal to 30. Less than 40, greater than or equal to 30, okay? Now if you notice here, I've got all of these here, so that's 19 people. And then I've got all those, plus if I added these 30 to those 40 right there, then that would be 19 and 19. So I got 38 people there. If you don't like that, count them all. All right? That's fine. I don't care. I like to count as quickly as I can. All right? And so I counted them by doing that. So those are my 30-year-olds. The next, less than 50 and greater than or equal to 40. By the way, do you see what I'm doing with my inequality symbols? I'm not including 30 there, but I am including 30 here. I can't have two equals because then I wouldn't know where that 30 goes. All right, so I'm including the 30 in the second one, not in the first one. Okay, now I need to count all my 40s. So all these, try that again, that's 19. There's another 19 right there. There's another 19 there. So that's 57. 3 19s is 57. 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68. So 68. I did not want to count all those. All right. Next, less than 60, greater than or equal to 50. So that's going to be these 19 and these 19. So that's 38. And we'll count 39, 40 for 1, 2, 3, 4, 5, 6, 7, 8, 9, 50, 51, 52, 53, 54, 55. How can I say the last one?
X is greater than or equal to 60.
X is greater than or equal to 60. I could say it that way. Just everything else bigger than 60. Okay? And I might want to do that even if I had one person that was 70, I may not want to put them in their own group. I may want to just put them in 60 plus, basically. All right? And so that would be this right here. From there to there would be 19, 20, 21, 22, 23. I don't know about you, but I like looking at this in that frequency table a whole lot better than just 200 random numbers. All right? I can see a lot more detail about it there. Okay? Is this the only way that we could have grouped them? No, you could have grouped them a lot of different ways. They may even tell you how to group them when they're asking you to graph it. Okay? Man, I don't know if I left anybody out. Did I leave anybody out? How could I check? I could add them all up. So if I add up all these frequencies, they should add up to be the 200. All right? So that would be a good double check for me if I needed to do that, so I could add all those up. Okay? Yep. Mm-hmm. All right. Now, let's draw a histogram that goes with this. Now, what is a histogram? Histogram is a bar chart, but it doesn't have any gaps. So that's the only difference between a histogram and a bar graph. Histogram is for continuous data, so we're not leaving any numbers out, so the bars are going to be touching. There's not going to be any gaps in this graph. Okay? So if I were to go do a histogram on this, actually I think I have enough space maybe to do it right here. All right? So I started with 30 and went 40, 50, 60. All right? So I'm going to do it this way. Everything less than 30, 16, all right? From 30 to 40, 38. 40 to 50, 68. 50 to 60 is 55. And the last one, 23. So there's what that looked like. That's the histogram. Okay? Really not any different other than the fact that there is no gaps. Okay? Is there any age value that I couldn't include on my graph? Well, we said X is less than 30, right? So it includes it, right? Make sense? So it's continuous. I'm not leaving anything out. There's not a number that you can't think of that I can't include up here. I mean, negatives, but that doesn't make sense in age. All right?
Yeah, I'm negative 4.
All right, yeah. All right, everybody good with that?
Yep.
One other thing. Does this graph look fairly symmetrical? It looks there's a little bit off. And so when we talk about the idea of skew, is this skewed? All right? This right here is pretty balanced. All right? But if I were to add boxes over here on this side, all right, if I had more things this way, then it's skewing it to the right. Okay? If I had boxes over this way where there's more boxes on this side, then it would be skewed to the left. Okay? But this one's fairly balanced. All right. One last thing and we're done for the day. All right? Last little idea is we're going to start looking at the data. All right? So we'll start doing some statistics now. And the first thing that I want to look at is measures of central tendency. So measures of central tendency. All right? you've done measures of central tendency, but you may not have said measures of central tendency. All right? We want to look at the middle of the data is what we look at. That's what measures of central tendency means. We're looking at the middle. There's three ways that we can look at the middle. Mean, median, and mode. There's three different ways to look at the middle of the data, to look at the central tendency of the data. Okay? We're going to talk about mode today, and then we'll be done. Okay? We'll save the other two for tomorrow. Okay? What does the mode mean?
The value that occurs most frequently.
The one that occurs most frequently. So mode and most go together in my opinion. They sound a lot the same, all right? But mode and most go together. So which one is the most? All right? We have this data set right here. Could you put this in a frequency table if you'd like? Yeah. Would it be super helpful? Not really, because there's a lot of different numbers that are not many of them are repeated, are they? Okay? Where's my mode? 15 is my mode. It is the one that happens the most frequently. So my mode for this data set is 15. All right? Yes?
Is it like frequently like it has to be 15, 15, 15, 15?
No, it could be anywhere. It doesn't have to be in any kind of order. Just which one shows up the most.
What if there's like two that are equal?
Okay, we'll talk about that here on in a second. All right? All right. So now a lot of times we may not see them just all written out like we just saw there. We may have already put them in a table. All right? So this is a frequency table. The number of goals I scored maybe in a soccer game or something. Okay? All right? And so here are all my games. I scored 0 goals in 4 games, 1 goal in 7 games. What's my mode of goals? 1. Because 7 is the most, all right? 7 was the most there, but what is it talking about? It's talking about 1 goal, all right? Could you write all these numbers out? 0, 0, 0, 0. I'd write it 4 times. Then I'd write a 1 7 times. 2, 3 times, so forth. Okay? Now, this gets weird with some people. It says find the mode or find the modal class. All right? When I put modal class on there, people don't recognize what that is. That's just kind of a plural form of mode. All right? So, what do we call this table over here? That's a grouped frequency table. That's exactly what that is. All right? So 0 to 5 seconds, 5 to 10 seconds, 10 to 15 seconds, so forth. All right? Where's my modal class?
In the 15.
15 to 20. It's the one that occurred the most. Okay? Now, what if this happened? In this experiment I did, what if something was wrong about this one and I had to throw that out? Now what's my modal class?
Either the 10 to
I have 2, right?
Yeah.
I've got 10 to 15 and I got 20 to 25. I have 2 that tied for that. What we refer to that is this data set is bimodal. Okay? So we would list both of them. If the data set has 2 modes, it would have bimodal. If it has 3, it would be trimodal, but at some point in time, it's not going to have as much effectiveness. If there's 3 things, all right? If you got 1 winner, that's pretty cool. Sometimes you have a tie, that's okay. But if you start getting like 4 or 5 winners, then it kind of gets watered down. Now, we're all winners, all right? So here we go. That's where I'm going to end. I'm going to put page 282 on the screen, all right? It's a pretty quick little page. You are telling me discrete continuous data, and you are telling me what type of sampling I'm using. On page 286, you are you're doing the bar graphs and stuff. Okay, so we've got about 5 or 6 minutes. You might could finish page 282 before we're done. I'll scroll and put it on the other page here in a second.